So this very miraculous result right here, in which there are exactly 6 different ways to append 2 lists to get the result A, B, C, D, E, and the query system found all of them, working with what's essentially just a rephrasing of the scheme append procedure. But the scheme append procedure only runs forward. You say 2 little lists, and it gives you a big list. And somehow, by couching it in logic programming terms, we get a relation that can figure out the constraints forward and backward to give you what you want. Now, it can't do something that can't be done. So if I gave it 3 variables, so say append question mark x question mark y question mark z, it's going to run forever, giving me sort of gibberish results. So there has to be enough information in your query that it really does constrain the problem. Also, I should warn you that not everything works backwards. So one example that you're going to see is if you try to write a reverse set of rules, a reverse relation in the obvious way, reverse this list, that list is true if one is the same as the other, only with the elements in the reverse order. You're almost certainly going to end up on your first try with something that works in one direction but doesn't work in the other direction. Come up with a version of reverse that really does the job bidirectionally. So what that means is that this abstraction, as we're presenting it here, is not perfect. So in order to make sure your program works, you have to think a little bit about how does the query system actually do the job that it's doing. I should say that this is a little toy query system that Abelson and Sussman wrote just for the purposes of this class. If you look at a real logic programming language, they've made great strides in being able to solve some of these problems, but I think it's still not perfect. Sometimes you have to help it out a little bit by saying, OK, don't go down here. If you do, you'll get in an infinite loop. So we want to see how the query system works. That's our job today. And I guess there's 2 pieces to that. And let me start with the piece that is sort of big in scope, which is sort of stepping back and looking at the big picture, which is right here. So here's schemes evaluator. It takes 2 arguments, an expression and an environment. I've drawn the environment off to the side because if you think about what it is you really want from scheme, you give it an expression and it gives you a value. And the fact that there's an environment involved is just sort of a detail. So this is sort of the main pipe through here. So I want you to compare this, which is scheme, with how the query system works. It takes a query as input. A query is like a scheme expression. It's something you type at the prompt. Right? You can type a scheme expression at the prompt, and out comes a value. You can type a query at the prompt, and out comes your query back again with values substituted for the variables that make it work. Well, what QEval returns is not a value. And what it takes in is not an environment, exactly. It's written to take a stream of environments. So you could think, if you had a lot of environments, you could just do them one at a time. In some situations, there are infinitely many answers to your question, or at least infinitely many potential answers. But it's worthwhile seeing them one at a time as they materialize, and you can just stop the computation when you're happy. So on the other hand, we don't want to write a program that says find something, print the value, find something else, print the value. That's not very elegant. And so what we do is we use the technique that we have for reordering computations, namely streams. So the QEval kind of on the side input here is a potentially infinite stream of environments. And in principle, we go through all those environments. An environment is a binding of variable names to values, right? Just like scheme, basically. And we try this query on each different environment, and whatever answers we get take the form of a new environment. And so the result is a stream of environments, again, potentially infinite. Each environment, this is unlike the metacircular evaluator, each environment is just one frame. And so you should ask yourself, how can that be? Because they have a scoping problem the same as scheme does about having a local variable in a particular rule that might be the same as a variable in some other rule. And they resolve the problem differently, which is as you're applying a rule, you systematically rename all the variables in the rule. So if the rule has a variable foo, then for this invocation of the rule, it's going to be foo 27 or whatever. And we substitute foo 27 for every place where foo appears. And the next time through, it'll be foo 28. So there's a global counter of how many rules we've applied that are used to make these names. And therefore, every variable name is unique. It only appears in one rule. But the same variable can appear in the body of the rule and the conclusion of the rule, and it really is the same variable. It has to have the same value. OK, so an environment is a single frame. A frame is, just like a scheme frame, almost. I'll talk about that in a second. And the input and the output from QEval is a stream of frames. Now, how could it be infinite? When you start out, well, what do you start out with? When you are typing something at the query system prompt, what's the equivalent of the global environment? And there aren't any predefined variables, because unlike scheme, there's no such thing as a primitive procedure, because there's no such thing as a procedure, period. OK? So the things that you might be misled into thinking are procedure names, like append up there, that's just a piece of text. It's the word append. It isn't bound to anything because it's not a variable. It's as if you said quote append in scheme. It's just constant text. The only variables are the things with question marks at the front. So what we start with is no bindings. And so you might think that a good starting point would be an empty stream. But it turns out, for technical reasons, that doesn't work. And what you need to do is start out with a stream of length 1 containing an empty frame. Because nothing's going to happen unless there's an environment for it to happen in. So we start out with one environment, i.e. one frame, that's empty. Now, the way QEval modifies its stream of frames in producing the output new stream of frames, there are 3 things it can do, I think. Let me make sure I'm getting this straight. One thing it can do is take a frame and add new bindings to it. So that would be, we've already bound some variables, let's say, from your original query, and now we're trying a rule, and we match the conclusion of the rule against your query, and that works. But that gives us some new bindings, because the rule has variables in it. So we would add those bindings to the frame, and that would make a new, bigger frame. The second thing that can happen is we can do what I just said more than once. We can take the same input frame and produce several, many, maybe infinitely many, output frames. Why is that? Because in order to get from the input frame to whatever output we need, we're going to what QEval does is it tries all the assertions and all the rules to see if they match the query that you're making. And so for every assertion and rule that matches, we get a new set of bindings. And it can get to be infinite because of recursive rules. So you can end up generating an infinite stream of frames that way. And of course, as usual with streams, what's really happening is they get generated one at a time, and the next one is generated only when we force a promise by taking streamcooter. Just, when we learned about streams the other week. Okay, so I guess one thing to add to this picture is that there's kind of an implicit input to every QEval call, namely a database that contains all the assertions and rules. So whenever you say assert bang such and such, you're adding to the database. And QEval, the database is it's a global thing in the evaluator. QEval always looks through the database to look for things that match your query. Okay. Oh, the third thing that can happen to a frame in this stream of frames is that it can be rejected. You can say, well, I'm sorry, you had a partial match, and then you tried to apply a rule, and now I'm evaluating the body of the rule, and I can't match that. So this set of bindings that you've given me is not going to work. Okay, so we can add to a frame, we can add new frames, and we can remove frames from the output stream of frames. It's not done by mutation or anything. It's producing a new stream of frames functionally. So that's pretty amazing, by the way. This is all functional programming in the implementation, except for adding to the database. That's the only non-functional part of it.